Hello everybody, this is the first video for the notes for section 5.3. In this video I'm just going to be talking about higher derivatives, which is just a derivative of a derivative. Alright, so when you take a derivative of a derivative, it is referred to as a second derivative. A derivative is still a rate of change, so we're talking about the rate at which the first change was changing. Now, as an example of that, you got to think a little bit of physics here. If we started with a position function and we take the derivative of that, a change in position is a velocity when you compare it to time, miles per hour. Now, if you take the derivative of a velocity, again, the derivative is a change in, so if we take the change in velocity, or talk about the change in velocity, we're talking about acceleration. All right, so dealing with the higher derivatives, there is some notation. All right, you're going to see this notation most often. The first one is f double prime, that's the second derivative, f triple prime, the third derivative. But you'll see this notation here on a somewhat regular basis, not as often, but just it tells you how many derivatives to find. So let's do some examples here. To find the second derivative, as this question is asking for here, you first need to find the first derivative. So just normal rules, no rules are changing or anything like that, it's just finding the derivative. So we're going to get 3x squared plus 12x minus 9. And now the second derivative is just the derivative of the first derivative. So 6x plus 12. And that's it. For this equation, for our second example here, let me slide this up a little bit. We're going to find the first derivative. To do this one, we got to do the chain rule. So 2 out in front, x squared minus 1, that goes to the first power times the derivative of the inside function. Now when you're doing higher derivatives, it is almost always to your advantage to simplify as much as possible before you go and take the next derivative. So for this one, we have a 4x times x squared minus 1. Because the exponent in this parenthesis is 1, we can just do some distributive property. It makes this thing even easier. 4x cubed minus 4x. There's our first derivative. Now the second derivative is just looking at the derivative of this right here. So 12x squared minus 4. That's our second derivative. Okay. And you can try this example down here. You have to do some quotient rule. Again, simplify things before you move on. And that's it for higher derivatives. Pay attention for the next video to talk about what that second derivative can tell us about a function.